Okay, so you can name it in terms of the range, the values that it's in, or you could say the 6th class or something like that, whatever you like to say.
I did it because like I saw it at the highest bar.
Yes, exactly. Yeah. What do you estimate the mean is? All right, so let's just shout out a couple. What do you think the mean is? Well, the exact mean of if you were to take all 50 pieces of data, just looking at the histogram, maybe you can make a guess. I don't know if that helps at all or what. Let's just shout out a few.
910.5.
890. 890 what? 0.57. Okay.
Cause like you know how like when you do it, we do it with the 0.5s and stuff, so like.
Okay.
903.66666.
903 points. Is that good? Okay. Anyone else want to throw up an estimate here? There'll be a prize for the person who's close.
Wait, really? Oh, wait, hold on. I want candy. Okay.
890.
Against or pie?
Isn't that alright? Oh, 890.
892.3.
890 what? 8 what?
892.3.
Anyone else want to offer up one?
894.
894.
Wow, you did not.
Alright guys, let's just break.
Alright, anyone want one more? One more? Anyone?
886.
886. Alright. Well, we already guessed a couple. Like there are a bunch of that made yours. Huh? 900. Alright, so well, I don't know.
Guys, clearly we're not understanding that process so
Did
no one get a part? Okay.
Wait, so the actual meaning?
God bless this unit for making me not have to use a notebook. I feel no better than my notebook. The national I just want to focus. I'm focusing on my future here and really considering
Yes, of course. So not shellfish.
I have a joke. Yeah, that's pretty good.
Can we stop with the jokes, please?
It's really good. I had my own
Hi, Mr. Chase.
Wait, Brent, I have a joke. Why
This is for my focus. I did really well when I sat here. I sat with this guts. Katie, did you have I remember when I used to
So, did your histogram last night look anything like this one?
Not quite.
In all of its glory? Hopefully it agreed with what I had up here, I don't know. So, as we think about how to come around histogram data or class data with statistical questions, we kind of run up against a couple issues. The first thing I might say is, I guess we should maybe even start by motivating why we think this would be the case. We have this situation where we might have lots and lots of data, and we just don't care to go calculate the mean because they're 50. Or imagine there were 5,000 pieces of data. You might not want to calculate the mean by hand. You might want to estimate it. You could also be in the situation, though, where you actually don't have access and never did have access to the original data. Can you imagine any kind of data that on the moment of collection, there was class data, and you don't actually have access to the actual number itself? Like, give an example.
Like you're looking at class data 1910 well, you don't know like what age is like the smartest or qualified or something.
Okay.
It's like everyone's version.
Yeah, I'll revise it. So have you ever taken a survey where it asks you to check the box? Are you between 18 to 25 years old? Are you between, right, whatever? Or, I don't know, what else could a survey like that ask? Income is a good one too. Income level. So after having collected that data, even immediately after you collected the data, you don't even know the ages of the respondents, right? You only know what category they fell in. So when you take a mean, if you want to say what the average age of the respondents is, say, you can't. You have to like lie a little bit. Like if you like, well, I made an estimate, but I actually never knew their ages exactly, so I can't find the actual mean. So there are a number of reasons why we might be dealing with class data and want to ask some statistical questions. So that's kind of the focus of what we're looking at and thinking about today. And so we'll think about, in particular, the measure substantial tendency, but then some other things as well. So the mode for a histogram is what Dinesh already said. It's just we can't really talk about a mode per se, but we can talk about the modal class. So that's the first question that we asked as you came in today. So just write that down again. This tracks with your packet here. The mean is a little bit trickier to maybe estimate, but we can get a decent estimate of it. The first thing you might have been doing, I don't know what your thoughts were as you made some guesses on the warm-up just now, as what you thought the mean might be. But we have conveniently, I'm so glad you like this assignment, by the way.
Oh, that's so pretty.
This is the histogram right here, cut out, and here it is in real life. Okay.
Can
So,
you keep it?
what?
Can you keep it?
No. This is like an heirloom quality teaching visual that I've made years ago.
Oh, that's true. Probably made it during lunch.
No. Actually, I have used it every year. For like 10 years.
Okay.
It's very old. But just to illustrate this first thing, it says that, and I made this point yesterday actually too. When I drew this picture on the board, remember we said the mean is sensitive to outliers, and I drew a distribution something like this. And I said the mean is no longer here if you move, like if you've got a chunk of the data that's been like moved over to here. The mean is like there or something, right? It's been moved to the right. Why? Well, because the mean in some sense has a physical manifestation too. It's in some sense like the fulcrum on which the whole distribution balances. So if you're looking for that. Now this one's pretty symmetric, so it's not very far off the center, but I marked the mean on here, right there. And this is a little bit of a lie, but at least it's a visual that'll help you remember that the mean is the place where the distribution balances. Wait for it. I don't know if you're emotionally ready for this.
It's the
On the unicycle, do it.
Wait for it.
We're ready.
Here, hold this. This is distracting me. I need to breathe.
Who was the day?
Nope.
Dinesh.
Hi. Thank you. Thank you. Thank you. I'm here all week.
It's
Actually,
all thanks to you, Dinesh.
that's not completely true. I'm taking off on this. But I mean, I do. Oh, actually, it's also a little bit of a lie because you could actually balance it other places too. That's not the mean though, you know.
Oh my god!
Do it on the weight tip.
Wait, watch
Down here.
Yeah.
Yeah, not that hard.
Yeah, it's a little bit. It's all lies. But you know, it's the point though. The point has been made. Okay.
I am not all lies. Did you hear what she said?
I don't believe that's your assigned seat. Okay. So are we good with that? Okay, so how can we compute the mean more accurately? By the way, on this slide is the reveal. Who said 890?
Woo!
Yeah, all right.
What's her prize? Does she get the histogram?
The actual mean is 889.48. If you go back to the original 50 pieces of data. Good job, Stephanie. I'm sorry, team.
Oh my god, I got a premio in Espanol and she got a premio in Matemáticas.
All right, so how would you get a better, imagine we don't have access to original data though, how could you get a more accurate, from this histogram, could you come up with a better approximation for the mean? You might have a procedure. Well, so for example, we see that from 770 to 810, whatever that one is, that 5 families use that much electricity. So we don't know what their actual electricity usage was, but let's pretend they all use how much? What would you like to pretend they all use? Huh? What are you doing? What are you looking for? Yeah, how about we just pretend that they all use exactly what the average of the limits or the boundaries are. We'll call this value the mid-interval value or the class mark. So that's just that average of those two numbers. And nobody in that category reported that usage. But we'll say that. Okay. So this is tracking along there somewhat, right? One of the families used between 690 and 730. How do we know that? You want to answer these questions on there? How do you know that? Because the chart says so? Okay. All right, moving on. Okay. If you calculate the class mark for the very first class, it's 710.5 is the halfway point, the class mark we're calling it. Or for the second class, it's 750.5. Notice that there's something interesting happening with these class marks. They're on the next page here. We're going to start calculating these going down here. Here are all the class marks. What do you notice about all the class marks? Well, yes, that's true, but what about the distance between them? Yeah, it is the same as the class width. So hopefully that's true if you've done everything correctly. Then it's not only true that the distance between class limits, lower class and lower class limit is 40, or upper class limit and upper class limit is 40, but also the distance between class marks, consecutive class marks is 40. So I think that's worth noting, and you can think about why that happens maybe too, is your answer to that question. By the way, if you correctly made boundaries, you can either use the class limits or the class boundaries and average them to get the class mark, right? Because if you made class boundaries in the correct way, you extended the class limits equally in both directions, and that preserves the class mark actually. So one more nice thing happening there. So the first couple of these have been done for you. The class mark is, for the first class, is 710.5 and its frequency is 1. Then we multiply those because we're calculating a mean, aren't we? We're just going to proceed with this frequency table as if this is the data, right? As if this is the representative piece of data. So we're going to calculate the mean, right? So take the value times its frequency, add them up, divide by 50 at the end, right? Do that, take a second, we'll all come back together in a minute so you can check with your neighbors, see what you get. We're on the second page for this, we're not. Correct. actual mean is 889.4 or something. 40. So just see, I think as you're coming, some of you are now coming to an answer now, finally, so just compare with the neighbor. But also just like step back and realize that this is a pretty decent estimate of the actual mean, even though at no time did you actually use the real data to calculate this estimate. You actually get a pretty decent estimate. It's not a universal truth that will happen, but this is not a bad way to do this, even if you don't have access to the data. I'll let you finish your work. But is there a fast way you could do this? Yeah, you could just do L1 and L2 again. And then do one bar stack with L1 and L2. Your calculator wouldn't know that those are class marks. It would just treat it like the normal data and it would work great. So feel free to do that in the function. In fact, you might want to do that. The next thing I'm going to ask you to do is just to calculate the standard deviation, just treating these as class marks as if they're real data. So you can maybe do that. And I don't want to like belabor that. All right, so what'd you get? So what'd you guys get? 8 something? 891.3. Is there agreement on that? 891.3. 891.3. Heard a couple people nod. Okay, all right, good. So not too bad. The real mean was 890. 8. What did we say? 889.48 or whatever it said. Yeah. So that's not too far off. Okay, so then, like I said, so I don't know if anyone calculated standard deviation, but that can happen just the same way with the class marks, just as the representative pieces of data. You have it. Go ahead. 84.0 ish.
I knew Katie would say it right.
It's only going to scare you.
I'm sorry. That's okay. Wait, hello.
I wonder how that would have gone.
I know, it probably wouldn't have gone well for me. I was going to say, I probably would have turned around, boom!
I see, thank you so much.
Now, what is this, so Katie?
Make a cumulative frequency chart, go.
I would have said that would have been so Katie takes a lot of money.
And then, but you do have the response on the question. Until you count it. I still get emotional until I stop. Until you count it, because I'm not very good at counting.
Good times, good
Bye,
times.
biscuits!
Bye, biscuits. I know, right? Aren't they cute?
Not mine, I never had this thing.
She's nice. You'll have her next year, I'm sure. Okay.
You're not going to request to have me?
I don't have that power. Otherwise, I would, Isai.
I
you know.
know.
I would. All right. So as you make these cumulative frequencies, we're going down here. It should end up being 50 when you're done. Why are we doing this? Eventually, we'd like to find the median. We'd also like to ask for other ranks, like the percentile, different deciles, quartiles, all those things, right? In order to do that, you remember back when we did like the whole TV example, right? We got like survey 600 people about how many TVs they had in their house, that example. And remember we made a cumulative frequency table for that? And the reason we did that, if you'll remember, was so that that could help us, and it did help us find whatever, the 44th percentile. We needed kind of benchmarks for where we were in the data. So that's all we're doing here too. It's really motivated by the same idea. So go ahead and do some addition. It's fun. 9, 19. It's relaxing, really. And then when you get 50 at the bottom, you can just smile at yourself and your great work.
Mr. Chase, I'm always smiling.
Suggesting that when you're right, you have an extra reason to smile.
Ah, right.
I know, I'm sure you have many other reasons in life to smile.
Thanks, Mr. Chase.
On the, let's just take a second to interpret what those even mean, though, in this context. For example, say we're looking at this 33 right here. Like, what does that mean, this number 33? When we were doing like that whole TV example, when we found a value like that was the cumulative frequency, we would say the value that was associated to, that many, there were 33 people who had that many TVs or less, is how we said that. So, but how do we say that here? There are 33 people who have what? Or less. I mean, we can't, there's a whole range of values here. What do we want to say? What can we guarantee? We can guarantee that there are 33 people who have less than, or household, that have less than or equal to what? Yeah, we can guarantee that we don't know much about the values in this range, but we do know that there are 33 that are less than or equal to this upper class limit, or upper class boundary. Right? So let's do that all the way along. Let's think about this is associated to this upper class limit, right? And in fact, actually, let's add one more cumulative frequency. Let's add 0 above our table here. And what number does that get associated to? 0 households or 0 households have this energy use or less. Yeah, so that lower class limit or boundary, you could kind of go either way. So we'll graph these points over here. And as you go to graph these points, so for example, this 33 one we were talking about, that would be you graphing the point 930.5, comma 33 on the graph. So in order to do this, though, you need to set up the scale. I really should have just provided the scale for you like this, but so here's the one I used. I think you have a replica of this on yours, so you can steal my scale if you like. 650, 700, 750. I went by 50s. Every 4 blocks, we block is 12.5 actually. It's a little bit of annoying, but go with it. And then on this scale here, on the vertical scale, I'm calculating, these are frequencies, so this is all 50 pieces of data. I went by 2s, so I had every 5 is 10, and then 5 more blocks is 20. You can steal my scale and then start plotting these points.
Mr. Chase, if we do a scale that doesn't start at 0, do you have to do a little break?
Technically, you probably should, yeah. So plot those points, but don't get, and it's a little bit tricky. They don't all land right on a grid, but it's really messy. All right, so I realize this is something that I want to give everyone a minute or two to deal with the advance of it. It's a little bit once you have plotted these as accurately as possible, don't connect them with a straight set of line segments.
it with the last, with the upper extreme for the intervals?
Well, because we want to say, like we said here, for example, that there are 33 households that used what amount of energy, or less than that.
Okay.
Well, we can't, especially because of the ones that are in this class, if we used a lower number than that, there might be some higher than that, you know. But what we can definitely guarantee is that the 33 of the households have an energy use of this, or less, right? Does that make sense?
Yeah.
I don't think.
He's been doing that for a while. If you don't know he's been doing it for a while, he discredits all the time he's been doing it.
Are you done? I'm just trying to buy you some time to finish your Ogive.
Oh, never mind, Wait, why is 690.50? Because isn't it possible that there's someone who did have 0? Because it's part of that, right?
690.5. No one had 690.5 or anything less than that. The lowest was 691, remember?
Oh. But like if we weren't given that data, then what would we do?
Well, the histogram makes that clear too, that there's, right? For the class data itself. If you told me that that's all the data, then there isn't any other data. It's outside the range 6, right? So you have to trust the person who gave you this class data, this data. If it wasn't me. Well, you know, I'm a juggler. I like to realize everything is a toy. You know? You gotta practice. So in addition to the homework activity tonight, you should all learn to balance something on your nose or your chin or your forehead. That doesn't everyone needs to learn how to operate a reverse pendulum.
If we do that instead of homework 2, do we lose
No.
our...
Thanks for asking. Okay. All right, your points should look something like this. And then I said, let's hold off on drawing straight line segments between those. Let's connect this with a smooth curve. If you want a fancy word for that, we're about to do some non-linear interpolation. Here we go. So as best you can, connect these with a nice smooth curve. Oh, that was not my best job of that, but I kind of undersold those 2 points there. Oh well. It's not too bad though. So do your best to do some non-linear by hand interpolate between the points there, okay? And then the question still remains, like, why did we do this again? Oh yeah, that's right. We're trying to find the median. Let's start at least with that. There are other things we can find from this chart. There are lots of things we could look at and say about the data from this chart. We should stop and say, by the way, I think I said it, but I want to actually highlight that this is sometimes called an ogive. It's not my favorite term for this picture, but it is the one that ID uses, and so you should know it. Okay, okay. It's Old English for, like, I think it goes, it's like a architectural term for like a arch of some kind or something. So maybe this looks arch-like. I don't know. It's not super helpful. I think a better name is, how about cumulative frequency diagram, because that's like what it is. So that's a good name for it, I guess. So how do you find the median? Where is the median in terms of like rank through the data? It's at position 25. So notice that as we find the median, or as we find other percentile ranks and things like that, you find it, go across horizontally to your ogive. So come this way across, and then look up that piece of data. Now yours and mine will be a little different, and everyone's will be a little different, because we'll have some discrepancy. But I'm getting around 912. Someone else do yours, tell me what you get. I'm getting around 912 as my, something in that neighborhood, as my estimate for the median. What do you think? Someone else? should tell us what yours is. Well, my grid lines are 12.5. So I said 912-ish or something, 913, somewhere here. Anyone have another number you want to throw out? What'd you guys get? 908. Okay. I mean, I think probably anything like within 10 of what I just said is probably okay, right? I mean, you can imagine if you drew yours a little different than mine, you might have got something different than 912. What other questions can be asked with this? Well, we have a couple on the next page there that we're going to ask about. You can look at it. So we just did the median. We said it's about 912. So there's something like that. You can please don't. There's nothing special about 9. Don't treat 9 as like the answer key. I think I said something different in my last class today. So whatever. Okay, but the point is, it's in that neighborhood. What else do we want to calculate? What? Q1, Q3, the IQR. We can get all these things. Where would Q1 be, say? Or how about Q3? Let's do that one first. Q3, where would that be? Yeah, it'd be 75% of the way through the data. So 75% of the way to 50 is 37.5. 2, 4, 6, 7.5. I don't know, somewhere in there. How about? Oh, I should have been using my ruler. Oops. I say it's 962 or something, right? What do you think? The Q for Q3? Someone check me on that. Someone have another number that is something around that? What'd you say? Yours it might be a little higher. I think my curve went a little low there. So maybe yours is a little low. But in that neighborhood around 962-ish. You can even ask about things like the next one there says the 23rd, one of them says the 23rd percentile or whatever. Okay, so go 23% of the way through the data. So that'd be to 11.5, position 11.5. Come across and come down. And it looks like it's around 812, something like that. Okay. The other thing we should say is that you could, and this is a miss for me on that worksheet. Yeah, you could go the other way too. If I said I have like 1,000 kilowatt hours was my home's usage, what percentile am I? Like you could ask the other question, couldn't you? And then you're doing this. You're coming vertical first, up, and then across to look up where you are ranked in the data. You see how extremely useful and exciting this diagram can be? Looks like we're at 42, 44, so 88, the 88th percentile. Come on, if that's not exciting, I don't know what is. Okay. By the way, I will say that it's we'll make you construct an Ogive like only a couple times in your life, but in general on the IB exams they make you they give you the picture usually, and then you make inferences from that. So then there's like a little less room for error between people. The homework is this worksheet coming to you right now. And learn to balance. Maybe use a broom or something. Something like that. Okay. Keep in mind that what you think is vertical is not vertical. Okay. You got a friend to spot you. Have a great day, everybody. Bye, everybody.